Evaluate the following limits. Okay, x squared plus x over x. You can see if you put 0 into this, you're going to get 0 over 0. So yeah, it is indeed a problem as written. Can we factor it? Yep. You can take an x out of the numerator, and you get x times x plus 1 over x, which is just what we needed. The x's cancel out. So with them gone, this function behaves like simply x plus 1. What does that do when you plug 0 into it? You get x plus 1, which comes out to 1, and that is your limit. For b, let's see, I'll just put 3 in the denominator because I have a pretty strong feeling it's going to come out to 0. 3 squared is 9 times 2 is 18. 18 take away 3 is 15. Take away 15 is, 0. So, how to fix? Again, factoring is probably our only hope. The numerator is a difference of squares. It factors as x plus 3, x minus 3. The denominator, this is a quadratic, so I'm going to have to do decomposition here. So I need two numbers that add up to minus 1 and multiply to minus 30. Those would be minus 6 and 5. If you're used to another factoring method, what I just said might sound like gibberish to you, but I promise if you factor this, you will end up in the same place that I'm going to. From these first two, I take out 2x, and that leaves me with x minus 3. From the second pair, I take out a 5, and that leaves me with x minus 3, so all good, yes. And the x minus 3 is canceled, just as we hoped. So our new improved function says, mostly I behave like x plus 3 over 2x plus 5. It's just that I lock up for a minute if you give me 3, because at 3, these guys, instead of canceling each other, produce 0 over 0, and that causes a undefined point. But mostly, I just act like this. So if we put 3 into this, we get x plus 3 over 2x plus 5. That would be 6 over 6 plus 5 is 11. And that ought to do it.